Okay, here we go. Problem 3-7. Says Bonnie and Dylan were both working on simplifying the expression at right. Each of their first steps is shown below. So here is our expression they started with. They had the product 2x to the fifth, y to the fourth, divided by 8x, y to the third, and they took the quotient of that and raised it to the third power. So we've got Bonnie here, and she has made it to this step. Dylan's looks a little bit different there. It looks a little bit more simple. So we're going to take it here and we're going to figure out what did they each do. So I've already got the problem set up down here. I've got Bonnie on the left, I got Dylan on the right. And what it looks like here happened with Bonnie is you notice there's no parentheses around the entire thing anymore. The third power is gone, which means she must have taken it and raised each piece or each term inside to the third power. Let's see what that looks like. So as we do it here, because there is no addition or subtraction, we can take it and raise each part to the third power. So we're going to end up with 2 to the third power, x to the fifth to the third power, and then y to the fourth to the third power. And that is going to end up being over 8 to the third power, x to the third power, and then we also have y to the third power. Now let's just simplify each of those. 2 to the third power is going to give us 8. X to the fifth raised to the third power is going to be like saying x to the fifth times x to the fifth times x to the fifth, which is going to give us x to the 15th power. And then when you take y to the fourth and raise it to the third power, we should get y to the 12th. 4 times 3 is 12. Now, looking down here, we've got 8 to the third, which 8 times 8 is 64, times 8 should give us 512. We've got x to the third power. And then we've got here y to the third raised to the third, which is going to be y to the 9th power. So you'll see here we've got exactly the same thing she got, so we see which step she already performed. Her next step here would probably end up then being to simplify this down. We could look at 8 and 512. So we know 8 goes into 8 once, and it goes into 512, I believe, 64 times. So right now we've got 1 over 64. We have x to the 15th over x to the third, which is going to give us x to the 12th over 1. And y to the 12th over y to the 9th is going to end up giving us y to the third over 1, because these 9 are going to cancel out 9 on the top. In the end, we end up with x to the 12th, y to the third, all over 64. Now that's Bonnie's answer. Let's look at Dylan now. Dylan, his expression that he ended up with was a lot simpler looking than what Bonnie had after her first step. So let's take a look here. It looks like he's still got the grouping symbols in here, so he's simplifying the inside. So let's look at it like that. We've got 2 over 8 times x to the fifth over x times y to the fourth over y to the third. Remember, the whole thing right now is still being raised to the third power, but I'm not that concerned about it right now. Let's just simplify. 2/8 is the same thing as 1/4. X to the fifth over x is going to give us x to the fourth. And that's just going to be over 1. And then we have y to the fourth over y to the third, which means we're going to end up with just a single y here over 1. Whole thing still raised to the third power, but let's look and see what happens when we simplify inside. 1 times x to the fourth times y gives us x to the fourth y. And that is over 4 times 1, which just gives us 4. And we'll put our expression back together here. So you'll see that's how Dylan made it to this part. Let's go ahead and simplify this now. Let's raise each part to the third power. So we're going to have x to the fourth to the third power. And then we've got y to the third power. And that whole thing is over 4 to the third power. We'll move it up a little bit here. So x to the fourth raised to the third power should be x to the 12th power. Our y is still to the third power, and then 4 to the third power should be 64. And if you look closely, just because we did it a different method here doesn't mean we get something different. Both these answers are the same thing. So did either of them make an error? No, they did not. It says, if not, explain how they can both be correct and verify that they will get the same correct solution. Which student's method do you prefer? Why? If it's me, I prefer the solution that Dylan used because he was able to simplify it down a little bit easier, I think, by simplifying the inside first and then raising it all to the third power. Obviously, you see over here, though, that doing it the opposite way does work as well. Now, what's one way you can verify that these are correct? You can plug in values for x and y, and after you plug those values in, you should get an overall value. You should get the same thing no matter which expression you use if they are truly equivalent there. I'd love to go through and show you how to do all that, but we've got several more videos that we need to do. If you have additional questions, please make sure you ask your teacher in class. Thanks for watching.